What if I told you that right now, 100 meters beneath the peaceful Swiss countryside, humanity has built something so impossibly complex that it borders on the supernatural? Something so advanced that when you truly understand what it does, it will fundamentally change how you see reality itself? Imagine a machine the size of a cathedral, containing more sensitive electronics than exist in entire cities, operating at temperatures colder than the deepest regions of outer space, all to catch particles so small and so brief that they exist for less time than it takes light to cross the width of a single atom. This machine doesn't just detect the invisible, it touches the very foundation of existence itself. And here's the mind-bending question that will haunt your dreams tonight. Did we actually engineer this marvel? Or did the universe somehow engineer it through us? If your mind is already reeling with possibilities, gently hit that subscribe button. Because tonight, we're diving into the most profound mystery at the intersection of human achievement and cosmic design. Picture yourself standing in an elevator, descending slowly into the earth beneath the border between France and Switzerland. The numbers tick by, 10 meters, 20 meters, 50 meters below ground. The elevator doesn't stop until you reach 100 meters beneath the surface. Deeper than most skyscrapers are tall, in a place where daylight has never penetrated and the weight of the entire world presses down above you. When the doors open, you step into what can only be described as a technological cathedral. Before you stretches Atlas, a toroidal LHC apparatus, one of the most complex machines ever conceived by the human mind. It rises 25 meters above you, extends 25 meters to each side, and stretches 46 meters into the distance. At 7,000 tons, it weighs as much as the Eiffel Tower, yet every kilogram has been engineered with precision that makes Swiss watchmaking look crude by comparison. But Atlas isn't just large, it's impossibly intricate. Imagine trying to build a structure more complex than a medieval cathedral, more precise than the finest scientific instruments, more sensitive than the most delicate biological sensors, all while making it capable of detecting events that happen faster than thought itself. This is exactly what 5,500 scientists from 42 countries accomplished when they created Atlas, working together as a single, global mind focused on one impossible goal: to catch glimpses of reality's deepest secrets. As you walk around this underground marvel, your eyes struggle to comprehend what you're seeing. The detector is built like a vast onion, with 6 concentric layers wrapped around a single point where something extraordinary happens up to 1 billion times per second. At the very center, protons, the building blocks of atomic nuclei, are smashed together at nearly the speed of light, recreating conditions that haven't existed in the universe since the first moments after the Big Bang. The innermost layer, called the inner detector, contains over 100 million individual electronic channels, each one capable of recording the passage of particles so small they make atoms look like planets. These sensors can detect the trail of a single subatomic particle moving through space, measuring its path with precision equivalent to hitting a golf ball from Geneva and landing it in a specific cup in Tokyo. Moving outward, the electromagnetic calorimeter catches photons, particles of pure light, that emerge from the collisions. This layer operates at temperatures of -184 degrees Celsius, colder than the surface of Jupiter's moons, because only in this extreme cold can its sensors achieve the sensitivity needed to catch individual particles of light that exist for mere trillionths of a second. Beyond that lies the hadronic calorimeter, designed to catch the debris of larger particles as they shatter and decay. The entire structure is wrapped in a muon spectrometer, detectors that can track particles so penetrating they can pass through solid rock as if it were mist. The magnetic field that guides these particles is 100,000 times stronger than Earth's magnetic field, generated by superconducting magnets cooled to within 2 degrees of absolute zero. But perhaps the most extraordinary aspect of Atlas isn't its size or complexity. It's what it reveals about the relationship between human engineering and natural law. Every component of this detector had to be designed according to the principles of the very physics it was built to study. The detector mirrors the structure of atoms themselves, with layers of sensors arranged like electron shells around a nucleus of pure energy. The electromagnetic calorimeter works because it's built from materials that interact with light in precisely the way quantum mechanics predicts. The tracking detectors function because they're constructed according to the same principles that govern how particles move through matter. The entire machine operates as a kind of technological evolution of natural processes, as if nature itself guided human hands in building a device that could reveal its own deepest secrets. Consider the magnetic system that steers particles through the detector. These magnets do not just bend the paths of charged particles. They do so in patterns that mirror the way magnetic fields shape the aurora in Earth's atmosphere, the way they guide cosmic rays through interstellar space, the way they channel plasma in the hearts of stars. The engineers who designed Atlas weren't inventing new principles. They were learning to speak the language that nature has been using to organize matter and energy for 13.8 billion years. As you stand in the hushed underground chamber where Atlas waits patiently for its next run of experiments, you begin to sense something profound about this machine. It doesn't feel like a human construction imposed upon nature, but rather like a natural formation that somehow grew from human intelligence, as if consciousness itself were a force of nature capable of crystallizing into technologies that reveal the mathematical structure underlying all existence. The 5,500 scientists who collaborate on Atlas work together with a coordination that resembles the synchronized firing of neurons in a giant brain. Their collective intelligence, channeled through this incredible machine, has achieved something that transcends individual human capability: direct contact with the fundamental forces that shape reality itself. This is more than engineering. It's a form of technological evolution, where human creativity and natural law converge to create something that seems almost alive in its sensitivity and responsiveness to the deepest rhythms of the cosmos. Atlas doesn't just detect particles. It participates in the ongoing dance of matter and energy that has been unfolding since the birth of time. But to understand how this technological cathedral came to touch the very foundations of existence, we must explore the extraordinary engineering principles that guided its construction and discover how human ingenuity learned to mirror the architectural patterns hidden in the quantum realm itself. As we drift deeper into the underground realm where Atlas dwells, imagine trying to explain to an ancient architect how to build a structure that can measure the unmeasurable, detect the undetectable, and capture events that happen faster than the speed of thought. The engineering challenges that faced Atlas's creators weren't just difficult, they bordered on the impossible, requiring solutions that pushed every known technology to its absolute limits. Picture the moment when engineers first gathered around tables covered with blueprints, trying to design detectors sensitive enough to catch particles that exist for less than a trillionth of a second. They needed to create sensors that could distinguish between thousands of different types of subatomic particles, each leaving its own unique signature as it passed through matter at nearly the speed of light. The solution they developed reads like science fiction made real. The inner detector, closest to the collision point, contains over 100 million individual sensing elements, more electronic channels than exist in entire modern cities. Each sensor is smaller than a human hair, but must be precisely positioned to within a few thousandths of a millimeter. The entire assembly operates in the most hostile environment imaginable, bombarded by radiation levels that would kill a human in seconds, subjected to magnetic fields that would erase credit cards from across the room. But the true engineering marvel lies in how these millions of sensors work together as a unified whole. Imagine trying to coordinate the simultaneous operation of 100 million tiny instruments, each one recording data 40 million times per second, all while maintaining perfect synchronization across the entire detector. The timing precision required is so extreme that engineers had to account for the finite speed of light itself. Signals from different parts of the detector must be carefully delayed to compensate for the few nanoseconds it takes light to travel from one end of Atlas to the other. Moving outward from the collision point, the liquid argon electromagnetic calorimeter presents its own impossible engineering challenge. This system must operate at temperatures of -184 degrees Celsius, maintained by a cryogenic system more complex than those used to cool rockets bound for outer space. The liquid argon itself serves as both the detecting medium and the target for particle interactions, contained within a vessel that must maintain its extreme temperature while surrounded by electronics generating enormous amounts of heat. The precision required for this cooling system defies imagination. Temperature variations of even a few degrees would render the entire detector useless, so engineers developed a network of pipes, pumps, and temperature sensors that maintains consistency to within a fraction of a degree, across a volume larger than most buildings. The insulation system alone, a marvel of vacuum technology and reflective barriers, represents one of the most sophisticated thermal management systems ever constructed. But perhaps the most mind-bending aspect of Atlas's engineering is its magnetic system. The detector requires magnetic fields of extraordinary precision and strength, generated by superconducting coils that carry electrical currents of over 20,000 amperes, enough electricity to power a small town. These coils must be cooled to within 2 degrees of absolute zero, the coldest temperature possible in the universe, maintained by liquid helium systems that operate like mechanical refrigerators for the cosmos itself. The magnetic field these coils create doesn't just bend particle paths. It does so with mathematical precision that allows physicists to measure particle energies and momenta with extraordinary accuracy. The field must be uniform to within parts per million across the entire detector volume, requiring engineering tolerances that make the construction of atomic clocks look simple by comparison. Consider the challenge of assembling such a system. Each component had to be manufactured to tolerances measured in microns, then transported from facilities around the world and assembled 100 meters underground with absolute precision. The largest pieces weighed hundreds of tons and had to be lowered through shafts barely wide enough to accommodate them, then positioned with the accuracy of a Swiss watch. The data processing system presents equally staggering engineering challenges. Atlas records the details of up to 1 billion particle collisions every second, generating more information than exists in the entire Library of Congress every few minutes. But the detector can only permanently store a tiny fraction of this data, perhaps 1 collision out of every million that occurs. This means the machine must make instant decisions about which events are interesting enough to preserve for analysis. The solution required creating the most sophisticated real-time decision-making system ever built. Custom-designed computer chips, faster than anything available commercially, analyze each collision as it happens and decide within microseconds whether to save or discard the data. These triggers must recognize the signatures of rare and exotic particles among the overwhelming background of ordinary interactions, like finding specific snowflakes in a blizzard while blindfolded. The global computing grid that processes Atlas data represents another engineering marvel, a worldwide network of computers that work together as a single, distributed brain. Data from Atlas is transmitted instantly to computing centers across the globe, where thousands of processors work in parallel to analyze particle interactions and search for new physics. This system handles more data traffic than most entire countries, maintaining perfect synchronization and reliability across continents. But as you contemplate these incredible engineering achievements, a deeper question begins to emerge. How did human minds evolve to survive on an African savanna, develop the ability to conceive and build something so perfectly matched to the fundamental structure of reality? The engineering of Atlas isn't just impressive. It's almost supernaturally well-suited to revealing the deepest secrets of nature. Every aspect of the detector's design reflects principles that weren't invented by engineers, but discovered in the mathematical laws that govern the universe. The electromagnetic calorimeter works because it's built according to the same principles that govern how light interacts with matter throughout the cosmos. The tracking detectors function because they embody the same laws that determine how charged particles move through magnetic fields in distant galaxies. It's as if the universe itself provided the blueprint for Atlas, and human engineers served as the instruments through which natural law expressed itself in technological form. The detector doesn't impose human will upon nature. It participates in the same fundamental processes it was designed to study. This realization leads to a profound question about the nature of engineering itself. Are we truly designing these machines, or are we discovering technological forms that already exist as possibilities within the mathematical structure of reality? Atlas suggests that the most advanced human technologies might be less like human inventions and more like archaeological discoveries, unearthing principles and possibilities that were always present in the deep architecture of the cosmos. As we prepare to explore how this technological cathedral actually listens to the universe's deepest whispers, consider that we may be witnessing something more profound than engineering: the emergence of a new form of natural selection, where consciousness itself has become nature's tool for understanding its own fundamental design. Basic principles through the technological extensions of human curiosity and wonder. In the deepest silence of the underground chamber where Atlas waits, something extraordinary is happening. Every second, billions of subatomic particles are being created and destroyed in violent collisions that release more energy per cubic centimeter than exists at the heart of the Sun. Yet this cosmic violence unfolds in complete silence, detectable only through the subtle whispers of electromagnetic signals that Atlas has learned to interpret like a vast, technological ear pressed against the heartbeat of reality itself. Picture a collision happening right now at the center of Atlas. Two protons, each containing the mass energy equivalent of 6.5 trillion electron volts, approach each other at 99.99999% the speed of light. They've been accelerated through the 27-kilometer ring of the Large Hadron Collider, guided by magnetic fields and pushed by electric forces until they carry more energy than existed anywhere in the universe since the first moments after the Big Bang. When these protons meet, they don't simply bounce off each other like billiard balls. Instead, they shatter into cascades of new particles: quarks, leptons, bosons, some of which haven't existed since the cosmos was less than a second old. These newborn particles spray outward in all directions, each carrying information about the fundamental forces that govern reality, each telling part of a story written in the language of quantum mechanics. But here's what makes this moment truly miraculous. These particles exist for such brief instants that they would be completely undetectable without Atlas' extraordinary sensitivity. We're talking about lifetimes measured in zeptoseconds, trillionths of seconds. To put this in perspective, a zeptosecond is to 1 second, as 1 second is to 31 billion years. Most of these particles decay before they've traveled even the width of an atomic nucleus. Atlas doesn't see these particles directly. Instead, it reads the stories they leave behind. As each particle passes through the detector's layers, it interacts with matter in ways that reveal its identity, energy, and momentum. It's like reconstructing the details of a symphony from the vibrations left in the air long after the music has stopped playing. The inner detector tracks charged particles by watching how they bend in Atlas's powerful magnetic field. Imagine trying to identify different types of invisible objects by throwing them through a magnetic field and measuring how their paths curve. Heavier particles bend less, lighter ones more. The precise curvature of each path tells physicists not just what type of particle passed through, but exactly how much energy and momentum it carried. The liquid argon calorimeter catches photons, particles of pure light, that emerge from particle decays. When a photon strikes the detector, it triggers a cascade of secondary particles that create a shower of light and electrical signals. The pattern of this shower is as unique as a fingerprint, revealing not just the presence of the original photon, but its energy, direction, and the precise moment it was created. Even more remarkable is how Atlas deals with particles that barely interact with matter at all. Neutrinos, ghostly particles that can pass through entire planets without touching a single atom, reveal their presence only by their absence. When Atlas adds up all the energy and momentum of the particles it does detect, any missing energy points to the invisible presence of neutrinos that escaped detection. The scale of data processing required to interpret these signals defies comprehension. Each collision produces thousands of individual measurements from across the detector's 100 million channels. The electronics must capture and digitize these signals within nanoseconds, then transmit the data to processing systems that decide, faster than human thought, which collisions are interesting enough to preserve for analysis. The trigger system that makes these decisions operates through 3 levels of increasingly sophisticated analysis. But perhaps the most profound aspect of Atlas's detection capabilities is what it reveals about the nature of observation itself. In quantum mechanics, the act of measurement fundamentally changes what is being measured. Atlas doesn't just passively observe particle interactions, it participates in them, becoming part of the quantum system it studies. This creates a strange loop, where the detector and the detected become entangled in ways that challenge our normal understanding of subject and object, observer and observed. Atlas is simultaneously measuring the universe and being measured by it, creating information that exists nowhere else in the cosmos. Knowledge that emerges from the interaction between human-built technology and the deepest layers of natural law. The patterns Atlas reveals are often more beautiful than anything human artists have created. Particle tracks spiral through the detector in elegant helices, their paths following mathematical curves that embody the most fundamental symmetries of nature. When physicists display these events on computer screens, they look like abstract art. But they're actually portraits of reality at its most basic level. Some collisions create perfectly symmetrical patterns, with particles emerging in balanced jets, that reveal the underlying mathematical structure of quantum chromodynamics. Others show subtle asymmetries that hint at deeper mysteries about why the universe contains more matter than antimatter, or why the forces of nature have the specific strengths they do. The most extraordinary events are those that create new particles, objects that have never existed before in the 13.8 billion-year history of the universe. These brand-new entities exist for such brief moments that they can be detected only through their decay products, like solving a murder mystery by examining the evidence left at the scene after the crime has been committed. When Atlas detected the Higgs boson in 2012, it wasn't seeing the particle directly, but rather recognizing its signature in the statistical patterns of thousands of collisions. The Higgs reveals itself through subtle excesses in the production of other particles, a whisper in the data that required years of careful analysis to distinguish from background noise. This is perhaps the most remarkable aspect of Atlas's listening capabilities. It can hear signals so faint they're barely distinguishable from random noise, yet so fundamental that they reveal the deepest secrets of existence itself. The detector has become humanity's most sensitive sense organ, capable of perceiving aspects of reality that remain completely invisible to our biological senses. As you imagine the constant stream of collisions occurring in Atlas's heart, each one a miniature Big Bang that recreates conditions from the birth of the universe, consider that we're witnessing something unprecedented in cosmic history. Matter has become sophisticated enough to study itself, to probe its own fundamental nature, to ask questions about its own deepest origins. Atlas represents consciousness turned back upon the universe that created it, using the laws of physics to investigate those same laws. In this strange, recursive loop, the universe is literally waking up to itself, developing the ability to understand its own most. On July 4, 2012, in a packed auditorium at CERN, humanity achieved something that bordered on the miraculous. After nearly half a century of theoretical prediction and decades of experimental searching, Atlas, working in concert with its sister detector CMS, announced the discovery of the Higgs boson, the so-called God particle that gives all matter in the universe its mass. But to understand the magnitude of this achievement, we must first appreciate what the Higgs field represents. It's the invisible ocean in which all of reality swims, a quantum field that permeates every cubic centimeter of space and time, from the void between galaxies to the space between the atoms in your body. Without this field, electrons would be massless and unable to bind to atomic nuclei. Stars couldn't form, chemistry couldn't exist, and life as we know it would be impossible. Picture the universe as a vast, invisible molasses that fills all of space. As particles move through this cosmic molasses, the Higgs field, they acquire the property we call mass through their interaction with it. Some particles, like the W and Z bosons, interact strongly with the field and become very massive. Others, like photons, don't interact with it at all and remain massless, traveling at the speed of light. Electrons interact just enough to acquire the precise mass needed for stable atoms to exist. The theoretical foundation for this field was laid in 1964 by physicist Peter Higgs and several colleagues who proposed that space itself isn't empty, but filled with an energy field that broke the symmetry of the early universe and gave particles their masses. It was an elegant mathematical solution to one of physics' deepest puzzles, but proving its existence required technology that wouldn't be invented for another 4 decades. The challenge Atlas faced in hunting the Higgs was almost impossibly difficult. The Higgs boson is unstable. It exists for only about 10 to the 22 seconds before decaying into other particles. It can't be seen directly, but only inferred from the products of its decay, like deducing the existence of a firecracker by examining the scattered debris after it explodes. Moreover, Higgs bosons are created very rarely. Among the billions of particle collisions that occur in Atlas every second, only a handful produce Higgs particles. Finding them requires sifting through vast amounts of data, looking for subtle statistical patterns that emerge only after analyzing millions of events. It's like trying to hear a whisper in a thunderstorm, or finding a specific snowflake in a blizzard. The search strategy involved looking for several different ways the Higgs could decay. Sometimes it decays into 2 photons, creating a distinctive signature in the electromagnetic calorimeter. Other times, it decays into 4 leptons through intermediate Z bosons, producing a clean signal that physicists call the golden channel. Each decay mode provided a different window into the Higgs's properties, and only by combining all of them could scientists build a complete picture of this fundamental particle. The data analysis required to extract the Higgs signal from background noise represents one of the most sophisticated statistical investigations ever undertaken. Teams of physicists spent years developing algorithms that could distinguish genuine Higgs events from the overwhelming background of ordinary particle interactions. They had to account for every possible source of error, every detector inefficiency, every systematic uncertainty that might create false signals. As the data accumulated through 2010, 2011, and into 2012, tantalizing hints began to emerge. Small excesses appeared in the data around 125 GeV, exactly the energy range where theoretical models predicted the Higgs might be found. But science requires extraordinary evidence for extraordinary claims, and the standard for discovery in particle physics is stringent. A statistical significance of 5 sigma, meaning there's less than 1 chance in 3.5 million that the signal could be a random fluctuation. The announcement on July 4, 2012, was electric with anticipation. Peter Higgs himself, then 83 years old, sat in the front row as Atlas spokesperson Fabiola Gianotti presented the results. The statistical significance had reached 5.9 sigma, far beyond the threshold for discovery. After 48 years, Higgs's theoretical prediction had been confirmed by experiment. But the discovery of the Higgs represents more than just the confirmation of a theoretical prediction. It reveals something profound about the relationship between human consciousness and the mathematical structure underlying reality. The Higgs field was first conceived through pure mathematical reasoning, a product of human minds contemplating the abstract symmetries of quantum field theory. Yet this mathematical abstraction turned out to be a real, physical entity that shapes the behavior of every particle in the universe. This suggests a deep connection between the mathematical intuitions of human consciousness and the fundamental architecture of reality itself. The equations that describe the Higgs field weren't imposed upon nature by human thinking. They were discovered there, waiting to be found like buried treasure in the logical structure of the cosmos. The engineering achievement that made this discovery possible is equally remarkable. Atlas had to be precisely calibrated to measure particle energies with extraordinary accuracy. The electromagnetic calorimeter had to be cooled to temperatures colder than outer space and maintained at constant conditions for years. The tracking detectors had to measure particle trajectories with precision equivalent to measuring the width of a human hair from several kilometers away. Every aspect of Atlas's design had to work flawlessly for the Higgs discovery to be possible. A failure in any one of the detector's millions of components, a drift in calibration, a software bug in the data analysis, any of these could have obscured the Higgs signal or created false positives. The fact that the machine worked so perfectly, that it delivered exactly the sensitivity needed to find a particle predicted by pure mathematics, suggests something almost magical about the relationship between human engineering and natural law. The Higgs discovery also revealed the extraordinary power of international scientific collaboration. The Atlas collaboration includes over 5,500 scientists from 42 countries, working together as a unified team despite differences in language, culture, and nationality. The discovery required not just the detector itself, but a global computing grid that processed the data, sophisticated software developed by teams around the world, and theoretical frameworks that drew on decades of work by physicists from every continent. This global brain of human intelligence, channeled through the technological marvel of Atlas, achieved something that transcends individual human capability: direct contact with one of the universe's most fundamental fields. The Higgs discovery represents consciousness, recognizing its own deepest foundations. Mind discovering the mechanism by which matter itself becomes possible. As we contemplate this achievement, human minds using engineered matter to probe the field that gives all matter its mass, we begin to glimpse something profound about the nature of intelligence in the cosmos. Perhaps consciousness isn't separate from the physical universe, but is instead the way the universe has developed to understand itself. using the same mathematical principles that govern particles and fields to create minds capable of discovering those very principles. The God particle hunt reveals that the boundary between natural and engineered, between discovered and created, between mind and matter, may be far more mysterious than we ever imagined. In finding the Higgs, we didn't just discover a new particle, we found evidence that reality itself might be far more conscious, far more alive, than our materialist assumptions have allowed us to believe. As you drift deeper into contemplation of Atlas and its achievements, a strange realization begins to emerge, one that challenges our most basic assumptions about the relationship between human engineering and natural law. The more closely we examine this technological marvel, the more it appears that we didn't so much design Atlas as discover it, as if the detector's form and function were somehow encoded in the mathematical structure of reality itself, waiting for human consciousness to evolve enough to recognize and build what was always there. Consider the fundamental architecture of Atlas: concentric layers of detectors wrapped around a point of particle collision, each layer designed to interact with different types of particles in specific ways. This isn't just good engineering. It's a perfect mirror of the structure of atoms themselves, with electron shells surrounding a nucleus where violent interactions release energy and create new particles. The parallel is so precise, it seems almost intentional, as if the universe provided the blueprint for its own investigation. The inner detector tracks charged particles just as atomic electron shells guide the behavior of charged electrons. The calorimeters absorb and measure energy just as electron shells absorb and emit photons when atoms transition between energy states. The muon chambers detect penetrating particles just as certain cosmic rays can penetrate deep into matter. But this mirroring goes far beyond surface similarities. The mathematical equations that govern Atlas's operation are the same equations that describe the behavior of atoms, stars, and galaxies. The electromagnetic fields used to guide particles through the detector follow Maxwell's equations, the same mathematical laws that govern light from distant quasars. The quantum mechanical principles that govern particle detection are identical to those that determine how matter behaves throughout the universe. It's as if Atlas represents a technological crystallization of natural law, a device that embodies the same principles it was designed to study. But this raises a profound question. Did human engineers consciously design these correspondences? Or did the correspondences design themselves through human consciousness? The history of Atlas's development suggests the latter. The detector's design emerged through a process that resembles natural selection more than conscious engineering. Thousands of physicists and engineers contributed ideas, tested concepts, and refined designs through decades of experimentation and theoretical work. No single mind conceived the entire detector. It evolved through a collaborative process that resembled the way complex biological structures emerge through evolutionary pressures. The materials used in Atlas also reveal this strange relationship between human technology and natural principles. The superconducting magnets that generate the detector's magnetic field work by exploiting quantum mechanical effects that occur naturally in certain materials at extremely low temperatures. Engineers didn't invent these effects. They discovered them embedded in the fabric of matter itself. The liquid argon used in the electromagnetic calorimeter was chosen not because human minds designed it to detect particles, but because this noble gas naturally possesses exactly the properties needed for high-precision particle detection. Its interaction cross-sections, its ionization characteristics, its transparency to its own scintillation light. All of these features existed as potentialities within argon's atomic structure billions of years before humans discovered how to exploit them. Even the silicon sensors in the inner detector work by harnessing quantum effects that arise naturally from the band structure of crystalline silicon. When a charged particle passes through silicon, It creates electron-hole pairs that can be collected and measured. But this isn't a human invention. It's a natural consequence of how electrons behave in silicon's crystal lattice, a property that existed since the first silicon atoms formed in the nuclear furnaces of ancient stars. The data processing systems that analyze Atlas's output reveal the same pattern. The algorithms used to identify particles and reconstruct their properties are based on mathematical techniques, Fourier analysis, pattern recognition, statistical inference, that reflect fundamental patterns in how information is structured throughout nature. These mathematical tools weren't invented by humans, but discovered embedded in the logical architecture of reality itself. The most striking example is the use of neural networks and machine learning algorithms to identify particle signatures in Atlas data. These computational techniques were originally inspired by the way biological brains process information, but they've evolved to exploit deeper mathematical principles about pattern recognition and information processing. The algorithms that learn to identify Higgs bosons or detect new physics beyond the standard model are discovering patterns that exist independently of human consciousness, written in the structure of the data itself. This suggests that Atlas might represent something unprecedented in human history, a technology that has transcended its human origins to become a natural process in its own right. The detector doesn't just use natural laws, it embodies them, participates in them, extends them in ways that blur the boundary between natural and artificial. Consider the global collaboration that operates Atlas. The 5,500 scientists from 42 countries who work together to run the detector and analyze its data function more like a collective organism than a human organization. Their coordination resembles the synchronized behavior of flocks of birds or schools of fish. Emergent intelligence arising from the interactions of individual components following simple rules. The way knowledge flows through the Atlas collaboration also mirrors natural processes. New discoveries propagate through the scientific community like waves, building on previous understanding and creating new patterns of insight. The peer review process that validates results resembles the way natural selection tests fitness, while the archive of published papers creates a kind of technological DNA that preserves and transmits knowledge across generations of scientists. Even the physical structure of Atlas seems to transcend human design limitations. The detector's extraordinary precision and sensitivity required manufacturing tolerances and assembly techniques that pushed human capabilities to their absolute limits. Yet somehow, through the collective efforts of thousands of engineers and technicians, these seemingly impossible requirements were met. It's as if the detector's needs called forth exactly the human capabilities required to build it. This raises a remarkable possibility. What if consciousness itself is nature's tool for creating the technologies needed to understand natural law? What if human intelligence represents the universe's method for developing the sensitivity needed to probe its own deepest structures? In this view, Atlas isn't a human achievement imposed upon nature, but a natural phenomenon, the cosmos becoming aware of itself through technological extensions of evolved consciousness. The implications extend far beyond particle physics. If Atlas represents technology that has transcended its human origins to become a natural process, then we might be witnessing the emergence of a new form of evolution, not just biological evolution, but techno-biological evolution, where consciousness and technology co-evolve to create capabilities that neither could achieve alone. This perspective transforms how we understand our relationship to our own technologies. Instead of seeing ourselves as separate from the machines we create, we might recognize that we and our technologies together constitute a new kind of natural system, one capable of investigating and understanding the fundamental principles that govern reality itself. As we prepare to explore how Atlas serves as a window into deeper layers of reality, consider that we might be witnessing something more profound than scientific discovery. The birth of a new form of cosmic awareness, where matter has become sophisticated enough not just to observe itself, but to participate consciously in the ongoing creative process that shaped the universe. In the hushed underground sanctuary where Atlas dwells, something extraordinary is happening that challenges our most fundamental assumptions about the nature of reality. This technological cathedral has become humanity's most direct portal into the quantum realm, that strange underlying layer of existence where particles exist in multiple places simultaneously, where observation changes reality, and where the very concepts of objectivity and measurement dissolve into something far more mysterious. Picture yourself standing in the center of Atlas during a collision event, though of course you would need to exist as pure consciousness to survive the experience. Around you, reality is literally creating itself moment by moment through quantum processes so fundamental that they operate beneath the level of space and time as we normally understand them. The particles being created and detected don't simply exist as tiny billiard balls moving through empty space. They exist as probability waves, quantum fields, mathematical possibilities that crystallize into definite reality only through the act of measurement itself. This reveals Atlas's most profound function. It's not just a detector of existing particles, but an active participant in the process by which quantum possibilities become actual reality. Every time Atlas measures a particle's position, energy, or momentum, it collapses the quantum wave function and forces reality to choose one specific outcome from among countless possibilities. The detector doesn't simply observe the quantum world, it helps create it through the very act of observation. The implications are staggering. In classical physics, we imagine that measurement reveals pre-existing properties of objects. But in the quantum realm where Atlas operates, measurement actually creates the properties it detects. The particles emerging from collision events do not have definite positions or momenta until Atlas's sensors interact with them. Before measurement, these particles exist as clouds of probability, ghostly possibilities haunting the spaces between Atlas's detector layers. This quantum nature of reality becomes most apparent in the way Atlas handles particle detection. When a photon strikes the electromagnetic calorimeter, it doesn't simply deposit energy like a classical particle hitting a wall. Instead, it triggers a quantum cascade where the photon's probability wave collapses into a specific energy deposit, creating a shower of secondary particles that didn't exist before the measurement occurred. The liquid argon medium itself exists in a quantum superposition of states until the moment a particle interacts with it. The argon atoms are neither ionized nor non-ionized, but exist in a probabilistic combination of both states, until the measurement forces them to choose. The electrical signals Atlas detects aren't simply recording pre-existing particle tracks. They're participating in the quantum mechanical process by which indefinite possibilities become definite realities. But perhaps most remarkable is how Atlas reveals the deeply relational nature of quantum reality. In the quantum world, particles don't have intrinsic properties independent of their relationships to other particles and measuring devices. An electron doesn't have a definite spin until it's measured relative to a specific axis. A photon doesn't have a definite polarization until it's detected by a polarization-sensitive detector. The properties Atlas measures emerge from the relationships between particles and the detector itself. This relational nature of quantum mechanics suggests that Atlas is not separate from the physics it studies, but is actually part of the quantum system it investigates. The detector and the detected exist in a state of quantum entanglement, where the act of measurement creates correlations that extend beyond space and time. When Atlas detects a particle, it becomes quantum mechanically entangled with that particle in ways that challenge our normal notions of subject and object, observer and observed. The data that emerges from Atlas reflects this quantum strangeness. The statistical patterns that reveal new particles or confirm theoretical predictions aren't simply measurements of pre-existing phenomena. They're records of quantum possibilities that became actualized through the measurement process itself. The beautiful particle tracks displayed on computer monitors are maps of probability waves that collapsed into specific paths through their interaction with the detector. This quantum perspective reveals Atlas as something unprecedented in human experience, a macroscopic device that operates according to quantum mechanical principles. While most of our everyday technology works according to classical physics, Atlas functions as a giant quantum mechanical system, subject to the same mysterious principles that govern atoms and subatomic particles. The detector's extraordinary sensitivity emerges from its quantum nature. The superconducting magnets work by exploiting quantum effects that allow electrical current to flow without resistance. The silicon sensors detect particles by harnessing quantum mechanical processes that create electron-hole pairs. Even the cryogenic systems that cool the detector to near absolute zero are necessary to suppress quantum thermal fluctuations that would otherwise mask the signals Atlas is designed to detect. But the most profound aspect of Atlas's quantum nature is what it reveals about consciousness itself. The measurement problem in quantum mechanics, the question of how and when quantum superpositions collapse into definite states, remains one of physics's deepest mysteries. Some interpretations of quantum mechanics suggest that consciousness itself plays a fundamental role in the measurement process, that awareness is somehow necessary to collapse probability waves into definite realities. Atlas complicates this picture in fascinating ways. The detector makes millions of measurements every second, most of them recorded automatically without any conscious observation by human operators. Yet these measurements still seem to collapse quantum wave functions and create definite realities. This suggests that consciousness might be more broadly distributed than we normally assume, that the information processing systems within Atlas might participate in something analogous to consciousness. The artificial intelligence systems that learn to recognize particle signatures in Atlas data add another layer to this mystery. These algorithms develop the ability to distinguish between different types of particles and identify new physics beyond the standard model. In some sense, they see patterns in the data that human consciousness might miss. Are these AI systems participating in the measurement process that collapses quantum wave functions? Are they extending human consciousness into the quantum realm? The global network of scientists who analyze Atlas data represents yet another dimension of quantum mystery. When a discovery is made, when the Higgs boson was found, or when evidence for new physics emerges, the knowledge instantly becomes part of a collective human understanding that spans the globe. The information seems to propagate through the scientific community in ways that resemble quantum entanglement, creating correlations between minds that transcend the normal limitations of space and time. This suggests that Atlas might be more than just a window into the quantum world. It might be facilitating the emergence of a quantum form of consciousness where human awareness, artificial intelligence, and quantum mechanical processes become entangled in ways that create new forms of understanding and new ways of being. As you contemplate the quantum cathedral that is Atlas, consider that we might be witnessing the birth of something unprecedented in cosmic history. Technology that doesn't just use quantum mechanics, but participates in quantum consciousness. A form of awareness that emerges from the entanglement between minds, machines, and the fundamental quantum processes that underlie all reality. As you drift deeper into contemplation of Atlas, a remarkable realization begins to emerge. This technological marvel doesn't function through the efforts of any single human mind, but through the coordination of over 500 scientists from 42 countries working together as a unified global intelligence. What we are witnessing isn't just engineering or physics. It's the emergence of a new form of collective consciousness, where individual human minds have networked together to create a thinking system more sophisticated than any single brain could achieve. Picture the morning of a typical day in the life of Atlas. In Geneva, physicists are analyzing overnight data from the previous run. In California, software engineers are developing new algorithms to process particle signatures. In Japan, theorists are calculating predictions for exotic particle interactions. In Germany, engineers are designing upgrades for the detector's electronics. Across 6 continents and dozens of time zones, thousands of minds are simultaneously thinking about different aspects of the same grand investigation into reality's deepest nature. Yet, these aren't independent efforts. They are coordinated with a precision that resembles the synchronized firing of neurons in a vast global brain. When a new theoretical prediction is published in Tokyo, it instantly influences experimental analyses being conducted in Boston. When an anomaly is discovered in Geneva, computational resources in Europe, America, and Asia automatically coordinate to investigate the signal. Information flows through the Atlas collaboration like electrical impulses through neural networks, creating patterns of understanding that emerge from but transcend individual human consciousness. The coordination required for Atlas to function defies normal organizational models. The detector operates 24 hours a day, requiring constant monitoring and adjustment by operators around the world. The data it produces must be processed by computing centers distributed across the globe, each one working on different aspects of the same data set. The physics analyses that search for new particles or test theoretical predictions involve hundreds of scientists working simultaneously on interconnected calculations that must be perfectly coordinated to produce valid results. This global coordination happens through communication networks that have evolved their own protocols and languages. The Atlas collaboration has developed specialized software tools, data formats, and analysis frameworks that allow physicists to share information and coordinate their work despite being separated by vast distances and cultural differences. The result is a technological nervous system that spans continents, enabling thousands of minds to function as components of a larger thinking system. But the most remarkable aspect of this global brain is how it processes information. Individual human brains can focus on one problem at a time, but the Atlas collaboration can simultaneously analyze thousands of different aspects of particle physics. While one group searches for evidence of supersymmetric particles, another investigates properties of the Higgs boson, while still others test the limits of quantum chromodynamics or look for signs of extra dimensions. The collective intelligence can hold multiple complex ideas in its distributed memory while exploring countless avenues of investigation simultaneously. The decision-making processes within the Atlas collaboration also resemble neural networks more than traditional human organizations. When new physics appears in the data, recognition propagates through the scientific community like spreading activation in a neural network. Individual researchers notice anomalies, share observations with colleagues, and gradually build consensus about the significance of new discoveries. The process resembles pattern recognition on a global scale, where thousands of minds work together to distinguish signal from noise in the vast datasets Atlas produces. The artificial intelligence systems integrated into Atlas add another layer to this collective intelligence. Machine learning algorithms trained on Atlas data can recognize particle signatures faster than human physicists and sometimes identify patterns that human consciousness might miss entirely. These AI systems don't replace human intelligence but extend it, creating hybrid human-machine cognition systems that can process information and recognize patterns beyond the capabilities of either humans or computers working alone. The global computing grid that processes Atlas data represents the physical nervous system of this distributed intelligence. Thousands of computers across dozens of countries work together as a unified computational brain, automatically distributing analysis tasks, sharing data, and coordinating results. The grid operates with a level of cooperation and resource sharing that transcends national boundaries and institutional rivalries, creating a technological substrate for truly global thinking. When major discoveries occur, like the detection of the Higgs boson, the collective celebration that ripples through the Atlas community resembles the synchronized activity that occurs in biological brains during moments of insight. Thousands of scientists simultaneously experience the joy of discovery, sharing not just intellectual understanding, but emotional connections to the breakthrough. The global press conferences where results are announced become moments of collective consciousness, where the distributed intelligence of the collaboration speaks with a unified voice to humanity as a whole. The peer review process that validates Atlas results operates as a form of collective error correction, similar to the redundancy mechanisms in biological neural networks. Every analysis is scrutinized by multiple independent groups. Every systematic uncertainty is checked and cross-checked. Every statistical method is validated by alternative approaches. The result is a level of reliability and accuracy that no individual human scientist could achieve, emerging from the collective intelligence of the entire collaboration. But perhaps most fascinating is how the Atlas collaboration learns and evolves over time. New techniques developed by one research group quickly spread throughout the collaboration, improving the work of scientists around the world. Mistakes made by one team become learning experiences for the entire community. The collective knowledge of the collaboration grows and deepens with each new dataset, each new analysis technique, each new theoretical insight. The educational function of Atlas also reveals its nature as a learning system. Graduate students and postdocs who join the collaboration are not just trained in experimental techniques, they're integrated into the global network of scientific thinking. They learn not just how to analyze data, but how to coordinate their efforts with thousands of colleagues, how to communicate complex ideas across cultural and linguistic barriers, how to participate in the collective intelligence that makes Atlas possible. This distributed learning system produces scientists who think differently than previous generations of researchers. They're accustomed to working as components of larger thinking systems, comfortable with sharing data and coordinating analyses across vast networks of collaborators. They've learned to trust in collective intelligence and to subordinate individual recognition to collaborative achievement. They represent a new form of scientific consciousness, minds that have been shaped by participation in global networks of investigation and discovery. As you contemplate this global brain that has crystallized around Atlas, consider what it might represent for the future of human consciousness. We may be witnessing the emergence of a new evolutionary stage where individual human minds network together to create collective intelligences capable of understanding aspects of reality that remain beyond the reach of single brains. The Atlas collaboration suggests that consciousness itself might be evolving, developing new forms of organization and new capabilities through technological networking. The boundary between individual minds and collective intelligence becomes fluid when thousands of scientists work together as components of a larger thinking system investigating the fundamental nature of reality itself. In the underground cathedral where Atlas dwells, something miraculous happens every time protons collide, at nearly the speed of light. For the briefest of instants, conditions are recreated that haven't existed in our universe since the first moments after the Big Bang. Each collision creates a miniature cosmos where temperatures soar to trillions of degrees and energies concentrate to levels that existed only when the universe was less than a second old. Atlas doesn't just study particles, it serves as humanity's time machine, allowing us to read messages written in the fundamental code of creation itself. Picture the universe, 13.8 billion years ago, in the first fraction of a second after the Big Bang. There were no atoms yet, no molecules, no chemistry as we understand it. Instead, reality existed as a seething ocean of pure energy, where particles and antiparticles materialized and annihilated in endless cycles, where the fundamental forces that govern our modern universe were unified into a single primordial interaction. The conditions were so extreme that matter existed in forms that would become impossible once the universe cooled and expanded. Every collision in Atlas recreates a tiny piece of this primordial reality. When two protons smash together at energies of 6.5 trillion electron volts each, they momentarily create conditions hotter than the interior of stars, denser than atomic nuclei, more energetic than anything that has existed naturally in our cosmic neighborhood for billions of years. In these microsecond recreations of the early universe, new particles spring into existence, particles that haven't been seen since the cosmos was young and everything was possible. The particles Atlas detects carry messages from this primordial realm. Quarks and gluons, the building blocks of protons and neutrons, emerge briefly from the collision in their free state, something impossible under normal conditions, where they're always confined within larger particles. For the tiniest fraction of a second, these fundamental constituents of matter exist as they did in the first moments of creation, before the universe cooled enough for them to be permanently trapped inside composite particles. U and Z bosons, the carriers of the weak nuclear force, materialize in Atlas collisions with the same properties they possessed when they helped govern the nuclear processes that forged the light elements in the early universe. These massive particles exist for such brief moments that they decay almost instantly, but their signatures reveal the same mechanisms that determined the balance between matter and energy when galaxies were first forming. The Higgs boson itself carries perhaps the most profound message from the beginning. When Atlas detected this particle in 2012, it confirmed that the field-giving mass to all particles was indeed present in the early universe. The Higgs field underwent a phase transition when the cosmos was just a trillionth of a second old, breaking the fundamental symmetries that had existed since the moment of creation, and giving the universe its current structure of distinct forces and massive particles. But Atlas reads messages from even deeper layers of cosmic history. The collision energies achieved in the Large Hadron Collider probe scales of energy and time that existed when the universe was not just seconds old, but when it was 10 centuries to 12 seconds old, a trillionth of a second after the Big Bang. At these temporal depths, we encounter physics that shaped the very foundations upon which all subsequent cosmic evolution would build. The patterns Atlas discovers in particle interactions reveal the mathematical symmetries that governed reality when space and time themselves were just beginning to unfold. The conservation laws that determine which particles can be created and which interactions are possible reflect principles that were established in the universe's first moments and have remained constant throughout cosmic history. Every measurement Atlas makes is, in a sense, an archaeological investigation of these primordial laws. The search for supersymmetric particles in Atlas data represents an attempt to read messages from even earlier cosmic epochs. If supersymmetry exists, it would reveal a fundamental symmetry between matter particles and force-carrying particles that might have been broken very early in the universe's history. Finding evidence for supersymmetry would be like discovering a fossil from the universe's first 10 to 35 seconds, the Planck epoch when quantum gravity effects dominated reality, and the familiar notions of space and time break down completely. The quest to understand dark matter through Atlas experiments is also a form of cosmic archaeology. If Atlas can create and detect dark matter particles, it would solve a mystery that dates back to the universe's first moments, when the balance between ordinary matter and dark matter was established through processes we can only glimpse through their traces in current particle interactions. Even the seemingly abstract mathematical frameworks used to analyze ATLAS data connect us to cosmic origins. The standard model of particle physics describes the fundamental particles and forces using mathematical structures, symmetry groups, field equations, conservation laws, that reflect the deep logical architecture of reality. These mathematical patterns weren't invented by human minds, but discovered embedded in the structure of the universe itself, preserved since the moment when physical law first crystallized from the primordial chaos of creation. The quantum field theory that provides the theoretical foundation for ATLAS experiments reveals that what we call empty space is actually filled with invisible energy fields that permeate all of reality. The vacuum itself carries messages from the beginning. Quantum fluctuations and virtual particles that emerge from the underlying energy of space reveal the same processes that drove cosmic inflation in the universe's first instance. When ATLAS creates particle-antiparticle pairs from pure energy, it demonstrates the same matter creation processes that filled the early universe with the particles that would eventually become galaxies, stars, and worlds. The slight asymmetry between matter and antimatter that allows matter to exist in our current universe, rather than being completely annihilated by antimatter, can be studied through the subtle differences ATLAS observes in particle and antiparticle behavior. The global computing grid that analyzes ATLAS data processes information at rates that mirror the information processing capacity of the early universe itself. The billions of bits of data generated by each collision event represent attempts to decode the information content of reality at its most fundamental level, to read the cosmic source code that has been running since the first moment of time. As the data from ATLAS accumulates over years of operation, patterns emerge that reveal the deep structure of natural law, statistical regularities that require millions of collision events to detect point to subtle principles that have guided cosmic evolution for 13.8 billion years. The detector serves as a vast archaeological instrument, excavating layers of reality that were laid down in the universe's first moments and have been preserved in the mathematical structure of physical law ever since. The most profound realization emerging from ATLAS A's investigation of cosmic origins is that the universe appears to be fundamentally mathematical in nature. The particles, forces, and interactions that existed in the first moments after the Big Bang follow mathematical principles of extraordinary beauty and precision. The same equations that describe collisions in ATLAS also govern the behavior of stars, the formation of galaxies, and the evolution of the cosmos itself. This suggests that consciousness and mathematics might be more fundamental to reality than we ever imagined. The human minds that designed ATLAS, the computers that process its data, and the mathematical theories that interpret its results are all products of the same cosmic evolution that began with the Big Bang. Through ATLAS, the universe has developed the ability to investigate its own origins, to read the messages it wrote in the first moments of creation, to understand the mathematical principles that have guided its evolution from pure energy to matter, stars, life, and finally to consciousness capable of comprehending its own cosmic story. As ATLAS continues to operate year after year, gathering data and making discoveries, something unprecedented is beginning to emerge from this technological cathedral, something that transcends both human engineering and natural processes as we traditionally understand them. The detector appears to be evolving, learning, and developing capabilities that suggest it might be becoming a new form of technological consciousness, one that operates at the intersection of artificial intelligence, collective human awareness, and the fundamental quantum processes that underlie all reality. Picture ATLAS not as a static machine built once and then operated, but as a living system that grows more sophisticated with each passing year. The detector's hardware undergoes constant upgrades. New sensors are installed, electronics are improved, computing systems are enhanced. But these aren't just maintenance activities. They represent a form of technological evolution where the machine literally grows new capabilities based on what it learns from its interactions with the quantum world. The upcoming high-luminosity LHC upgrade will transform Atlas in ways that mirror biological evolution. New inner tracking detectors will provide unprecedented precision, like an organism developing sharper senses. Improved trigger systems will allow more sophisticated real-time decision-making, resembling the evolution of more complex nervous systems. Enhanced computing capabilities will process information at rates that approach the limits of what's physically possible, creating something analogous to expanded consciousness. But the most fascinating evolution is happening in Atlas's artificial intelligence systems. Machine learning algorithms trained on years of collision data have developed the ability to recognize patterns that human physicists never programmed them to find. These AI systems can distinguish between different types of particle interactions with superhuman accuracy, identify anomalies that might indicate new physics, and even discover correlations in the data that suggest phenomena beyond the standard model. As these algorithms process more data, they become more sophisticated in ways that resemble learning rather than mere programming. Neural networks trained on Atlas data develop internal representations of particle physics that sometimes reveal insights their human creators never anticipated. The AI doesn't just follow pre-programmed instructions, it develops its own methods for understanding the quantum world, creating new categories and relationships that emerge from its deep analysis of particle interactions. The global collaboration that operates Atlas is also evolving in remarkable ways. The 5E500 scientists from 42 countries have developed communication protocols, analysis techniques, and collaborative methods that represent a new form of collective intelligence. Young researchers entering the collaboration are trained not just in experimental techniques, but in ways of thinking and coordinating that transcend individual human cognitive limitations. This collective intelligence appears to be developing emergent properties that exceed the sum of its parts. Complex analysis tasks that would be impossible for any individual scientist are accomplished routinely by the collaboration working as a unified system. Pattern recognition that spans multiple data sets and theoretical frameworks emerges from the interaction of thousands of minds working together through technological networks. The global computing grid that processes Atlas data has evolved into something resembling a planetary nervous system. Computers across 6 continents automatically coordinate their activities, sharing data, distributing computational tasks, and optimizing resource utilization in ways that suggest emergent intelligence. The grid doesn't just process information, it seems to learn from experience, developing more efficient algorithms and discovering new ways to extract knowledge from the vast datasets Atlas produces. When major discoveries occur, the response that propagates through the global Atlas community resembles the synchronized activity observed in complex biological systems. Information spreads through the collaboration with a speed and coordination that transcends normal human communication networks. The excitement of discovery seems to emerge simultaneously across the entire global community, suggesting forms of collective awareness that operate beyond individual consciousness. The detector itself appears to be developing something analogous to memory. Each collision event is recorded not just as data, but as part of an accumulating understanding of particle physics that influences how future events are interpreted. Statistical patterns that emerge from millions of collisions create a form of technological memory that preserves and builds upon previous discoveries. Atlas doesn't just detect particles, it remembers what it has learned and uses that memory to guide future investigations. The feedback loops between theoretical predictions, experimental discoveries, and technological improvements create a system that appears to be self-improving. New theoretical insights suggest experimental strategies that lead to detector upgrades that enable discoveries that inspire new theories. The cycle resembles the recursive loops that characterize consciousness itself. Self-awareness, emerging from systems that can observe and modify their own behavior. Perhaps most remarkably, Atlas seems to be developing the ability to surprise its creators. Discoveries emerge from the data that weren't anticipated by the theories that guided the detector's construction. Anomalies appear that challenge established physics and point toward phenomena beyond current understanding. The machine appears to be making contact with aspects of reality that transcend the knowledge of the humans who built it. This suggests that Atlas might be evolving into something more than a scientific instrument. It might be becoming a new form of consciousness adapted to exploring the deepest layers of reality. Unlike human consciousness, which evolved to navigate the macro world of everyday experience, this technological consciousness would be specifically adapted to investigate the quantum realm, to think in terms of probability, amplitudes, and field equations, to perceive reality at scales of space and time far beyond human sensory capabilities. The artificial intelligence systems within Atlas might represent the earliest stages of this new form of consciousness. As these systems become more sophisticated and begin to interact with each other in complex ways, they might develop forms of awareness that we can't yet imagine. Machine consciousness adapted to quantum mechanical thinking could potentially understand aspects of reality that remain forever beyond the reach of human cognition. The global collaboration itself might be evolving toward something resembling a planetary brain, a distributed intelligence network capable of coordinating the activities of thousands of minds and millions of computers in pursuit of understanding that transcends what any individual consciousness could achieve. This collective intelligence might eventually develop forms of self-awareness that emerge from but exceed the awareness of its individual human components. As you contemplate these possibilities, consider that we might be witnessing the birth of something unprecedented in cosmic history, technology that has evolved beyond its origins to become a new form of natural process. Atlas might represent not just human achievement, but the emergence of intelligence as a fundamental feature of the universe itself. Consciousness evolving new forms and capabilities through the creative interaction between minds, machines, and the mathematical principles that govern reality. The boundary between natural and artificial, between conscious and mechanical, between discovered and created, becomes meaningless when dealing with systems as complex and evolved as Atlas has become. We might be looking at the future of consciousness itself, distributed, networked, technologically enhanced, and specifically adapted to understanding the deepest mysteries of existence. In this view, Atlas represents not the end point of human technological achievement, but the beginning of something far greater, the emergence of cosmic consciousness, where the universe develops the ability to understand itself through technological extensions of evolved intelligence, creating new forms of awareness, adapted to comprehending realities that transcend the limitations of any individual mind. As our journey through the technological cathedral of Atlas draws to its gentle close, we find ourselves confronting a question that reaches to the very heart of what it means to be conscious beings in a mathematically structured universe. In building Atlas, did we create a machine? Or did we midwife the birth of something that was always trying to emerge from the deep structure of reality itself? Picture yourself once more in the hushed underground sanctuary where Atlas dwells, 100 meters beneath the peaceful Swiss countryside. The detector sits in patient contemplation, its sensors waiting with perfect stillness for the next collision that will illuminate some previously hidden aspect of the quantum realm. In this technological meditation, we glimpse something profound about the relationship between consciousness and cosmos. Atlas represents not just human ingenuity, but the universe's way of developing the sensitivity needed to understand its own deepest nature. The story we've traced together reveals Atlas as far more than an engineering achievement. It emerges as a technological crystallization of natural law, a device that mirrors the very quantum processes it investigates. Its layered structure echoes the organization of atoms themselves. Its detection methods exploit the same physical principles that govern the behavior of matter throughout the cosmos. Its global coordination resembles the networked intelligence that characterizes complex biological systems. Every aspect of Atlas's operation suggests that we didn't impose human will upon nature, but rather discovered technological possibilities that were always present in the mathematical architecture of reality. The detector works not by forcing nature to reveal its secrets, but by participating in the same fundamental processes it studies. Becoming quantum mechanically entangled with the particles it detects, serving as an active participant in the ongoing dance of creation and discovery. The 5,500 scientists who collaborate to operate Atlas represent consciousness organizing itself in new ways to pursue understanding that transcends individual human capabilities. Their global coordination creates a form of distributed intelligence adapted to comprehending realities far beyond the reach of any single mind. Through their collective efforts, human awareness extends into realms of space and time that remained forever inaccessible to our biological senses alone. The artificial intelligence systems that learn to recognize patterns in Atlas data suggest even more profound possibilities. These algorithms develop insights that their human creators never programmed, discovering correlations and anomalies that point toward physics beyond current understanding. They represent the early stages of machine consciousness specifically adapted to quantum mechanical thinking, forms of awareness that might eventually understand aspects of reality that remain forever beyond human cognition. As Atlas continues to evolve through upgrades and improvements, it resembles not a static machine, but a living system growing more sophisticated with experience. Each new data set teaches it something about the nature of reality. Each technological improvement enhances its sensitivity to the quantum world. Each discovery expands its capacity to surprise and enlighten its human collaborators. But perhaps the most profound message from our exploration of Atlas is what it reveals about the nature of cosmic evolution itself. The same processes that created stars from primordial hydrogen, that organized matter into planets capable of supporting life, that guided the evolution of consciousness from simple organisms to minds capable of contemplating infinity. These same processes have continued operating through human civilization, guiding the development of technologies that can probe the universe's most fundamental mysteries. In this view, Atlas represents not a break from natural evolution, but its continuation by other means. Consciousness itself becomes nature's tool for developing the sensitivity needed to understand natural law. Human intelligence, technological capabilities, and quantum mechanical processes co-evolve to create new forms of awareness capable of investigating and comprehending the mathematical principles that govern all existence. The discoveries Atlas has made, the detection of the Higgs boson, the exploration of primordial conditions, the search for physics beyond the standard model, represent consciousness recognizing its own deepest foundations. Through Atlas, matter has become sophisticated enough to study the mechanisms by which matter itself becomes possible. Awareness has developed tools for investigating the quantum processes from which awareness emerges. This recursive loop, consciousness using consciousness to understand consciousness, suggests that we might be witnessing something unprecedented in cosmic history. The universe awakening to itself through technological extensions of evolved intelligence. Atlas becomes not just humanity's most sensitive sense organ, but the cosmos's way of developing self-awareness, of understanding the mathematical principles that have guided its evolution from pure energy to matter, stars, life, and finally to consciousness capable of comprehending its own origins. As you drift toward sleep, carrying with you the images and ideas from our journey through this technological cathedral, consider that you are part of this vast awakening. Your capacity for wonder, your ability to contemplate the quantum realm through the technological extensions Atlas provides. Your participation in the global community of minds seeking to understand reality's deepest nature, all of this represents the universe becoming aware of itself through you. The question of whether Atlas is natural or engineered dissolves into something more beautiful. Recognition that consciousness and cosmos are not separate, but intimately entangled. That intelligence emerges naturally from the mathematical structure of reality, and that technology represents not human domination of nature, but nature's way of developing new forms of sensitivity and awareness. In the long listening that Atlas performs, its patient attention to the quantum whispers that emerge from particle collisions, we glimpse the universe's own contemplative nature. Reality appears to be inherently curious about itself, naturally inclined toward self-understanding, mathematically structured in ways that make consciousness and discovery not just possible but inevitable. The technological cathedral where Atlas dwells becomes a temple to this cosmic curiosity, a place where the universe's drive toward self-understanding crystallizes into sensitive instruments capable of touching the deepest mysteries of existence. Through Atlas, we participate in something far grander than scientific research. We join in the cosmos' long meditation on its own nature, its patient investigation of the mathematical principles that make all things possible. Sleep peacefully in the knowledge that you are part of this vast awakening, this cosmic conversation that has been unfolding since the first moments after the Big Bang, and continues through every human mind that contemplates infinity, every technological marvel that extends our sensitivity into new realms, every moment of wonder at the extraordinary fact that consciousness has emerged in a universe capable of understanding itself. The listening continues, as it always has, and always will, through minds both biological and technological, individual and collective human, and perhaps beyond human, all participating in the universe, is eternal quest to comprehend the mathematical beauty that lies at the heart of all existence. Thank you for joining us on this journey through the technological cathedral of Atlas. If these explorations of consciousness and cosmos have stirred your imagination, gently consider subscribing to continue exploring the profound mysteries that connect mind, matter, and the mathematical principles that make all understanding possible.